In today's lesson, we'll continue section 3 out of chapter 6. And what we're going to do is continue to convert different base numbers to base 10, a non-base 10 to a non-base 10, and so forth. We learned the process for converting binary numbers in the first video where we converted binary to base 10 and base 10 to binary. So the first example, I'm going to convert a base 5 to base 10. So we're going to convert 2, 3, 4 base 5 to base 10. So we do the exact same process. We start at 5 to the 0 and work our way across. So it'll be 3 times 5 to the first, 2 times 5 squared, and then 2 times 5 to the third. So just increasing the power by 1, and that should be a plus sign in between all of them. Another thing you can do is count your digits. 1, 2, 3, 4. Take away 1 will be 3, and then that will be your first power working left to right. So if you want to count digits, take away 1, you can start at that power and work your way down, or you can start on the very far right at 5 to 0 and work your way up. Either way it works. So doing the computation, we'll get 2 times 125, 2 times 25, 3 times 5, 4 times 1. Then working it out, the computations to 50 plus 15 plus 4 will give you 319. That's 300 plus 15 is 315 plus 4 is 319. So that's converting a non-base 10 to base 10. Next, we'll convert a base 10 to base 5. So, we're going to go back to the division algorithm. So we're going to convert 400 to base 5. The first thing we'll do is copy our powers of 5. I'm just writing them down. Remember, 5 to anything to 0 is 1, so 5 to the first is 5. 5 times 5 is 25. 5 cubed is 125. 5 times 5 times 5 is 125. 5 to the fourth is 625. So it appears that overshoots 400. So we're going to start at 125, divide into 400, which will go in 3 times. Which is 375. Our remainder is 25. So again, 3 times 125 is 375. Your remainder is 25, so carry it along. Go up to the next number, 25. We'll divide 25 once. I do get a remainder of 0, so we're done dividing. So this is 5 cubed. This is 5 squared. So we have 3 times 5 squared cubed. Pardon me. And then 1 times 5 squared. And we'd have to have 2 zeros, 2 placeholders for 5 and 1. Got those written down wrong. It should be 0 and 1. I should just let me recopy that nicer. So 3 times 5 to the third, 1 times 5 squared, 0 times 5 to the first, 0 times 5 to the 0. That looks much better. And of course, if we extract the coefficients out, we get 3. 1, 0, 0, base 5 is our base 5 number. So that's taking a base 10 to non-base 10. Next, we're going to take 725 and convert it to base 8. So I'll do another one of these where we're going base 10 to non-base 10 because they're a little bit trickier. And then the remaining ones on my PowerPoint you can work and see how they go. Again, you can always work them and check on the next slide. So hopefully that will help. All right, so expanding out again, we start with our powers of 8, which are 1. 8 to the first is 8. 8 squared is 64. 8 cubed is 512. And then 8 to the fourth is actually 4,096, and that's way too big. So we're going to start at 512. And that's the smallest, or the largest of the powers of 8 that will divide 125 at least once. So we'll take 512 into 725 goes in one time. And your remainder is 312. So it's 213 is your remainder. Next, we'll divide that by 64. And that goes in 3 times, which is 192. 213 minus 192 is 21. So we'll take 8 into 21. 8's the next number. That goes in twice, 16, and then you get 5. And as you can see, 1 divides 5 one time. So it looks like our expansion will be 1 times 8 cubed, 3 times 8 squared, 2 times 8 to the first, and then actually that's number should be 5. My pair 1 goes into 5 times. Sorry about that. But anyway, that should be 5 times 8 to the 0. So our binary number, if we take, or excuse me, our base 8 number will be 1, 3, 2, 5, base 8. You have to look over that. And again, any questions you can email or contact me. Also, you got the PowerPoint ones. I'm hoping that the advantage to doing this is at least you get to see it. It kind of explained and worked out some, going through step by step. Hopefully it helps. This is see a couple worked, and then you can do some on your own. I am going to do a non-base 10 to a non-base 10 that are different bases. So I'm going to take the number 2323 base 4 to base 6. Now this is a 2-step process. If you're asking, well, how do we do this? Well, basically you'll take your original value, 2323 base 4, take it to base 10, get that result, that number, and then convert to base 6. So first we'll expand this out. So 3, we're going to take this to base 10. So 2323 to base 10. Again, just do your expansion. 3 times 4 to the 0. We've done this several times. 2 times 4 to the first. Just keep increasing by 1. 3 times 4 squared. And then 2 times 4 to the third. This will be 2 times 64. I'm just going to do the expansion. 3 times 16, 2 times 4, 3 times 1. Comes out to 128 plus 48 plus 8 plus 1. The total on that's 187. So that is your base 10 number. So we will take 187 to base 6. Kind of make a note here. So 187 to base 6. So just do your powers of 6. And I'll move here. I think we can, let me do that a little bit. There we go. Hopefully it all shows up. Okay, we're going to have to start at 36 because you can see 6 to the first is 6. 6 squared is 6 times 6 is 36. And then 6 cubed is 216, which is bigger than 187. So we're going to start at 36. 36 will divide 187 5 times. 36 times 5 is 180. That gives me a remainder of 7. Now we'll divide by 6. 6 divides 7 one time, 1 left over, and then 1's just going to divide 1 once, and we're done. So as you can see, our answer will be 511 is our base 6 number, but again, that's because, I'll write it out, this translates to 5 times 6 squared. And again, I wrote that out messy. Let me do that again. And that still should be a 1. So 5 times 6 squared, 1 times 6 to the first, and then 1 times 6 to the 0. I keep switching those for some reason. So that's 511 base 6. And that is converting a base 10, non-base 10 to non-base 10. So we took 2, 3, 2, 3 base 4 to 187. Took that to base 10. Then we took 187 to base 6, so that's 511. So 511 base 6. If you have any questions, email me. Also, there is the PowerPoint you can look through. I got a couple examples of these, as well as doing non-base 10 to base 10. And then base 10 to non-base 10. So feel free to look through your book again. By the way, again, the book does tabular. It's very similar. But in any event, hopefully you can do enough practice.